This is a follow-up to our day one discussion on chain rule, and this is what we discussed the other day. So basically, if you do have the power rule here, you're going to take the derivative with a different function as the base. Well, you do your power rule, and then you take the derivative of the function inside. If you have it set up like this, where you have a function within a function this way, well, then you take the derivative of the outside function, the f of x, you leave the inside function, and then you multiply it by the derivative of that inside function. The textbook likes to use u instead of g of x. If you notice, it's the same thing as that, just has a u instead of g of x. All right, so let's do this example over here. And in order to do that, we will need to also remember this one right here. So I just left it there. We are asked to find the derivative of 4 times the cosine of the square root of 5 minus 4x squared. This right here is how we're going to go about it. First, before I write dy dx, I want to rewrite my function. This is not, that's 4 cosine, and we have 5 minus 4x squared raised to the 1/2. Now we'll continue with dy dx. This right here is just a 4 times. It's not a 4x or a 4x squared. So we don't have to use the product rule like we discussed in class. You're going to leave that constant and take the derivative of the function with the x's in it, the variable. So that one becomes negative sine. Now if you look over here, right, this becomes, whatever this is, if it's negative sine of that, and in this case our u value is this. And then we're going to take the derivative of that and multiply it over here next to it. So let's continue. So we have negative sine. We leave the 5 minus 4. Let me make that 5 look better. Hold on. Okay. Now we multiply by the derivative of that. And that is going to look like this. We need to use a chain rule for that. And I think once you see the answer here, it should make sense to you. And then we multiply that by negative 8x. Let's recap here. All right, so we left the constant here. I took the derivative of the cosine function, which was negative sine. I left my u value. And then over here, it's time to take the derivative of u. We have to use the chain rule. You put the 1/2 in front. You leave your base, and you reduce the exponent by 1. Now when it's time to take the derivative of the base, well, that becomes, the derivative of the base becomes negative 8x. That's where that came from. While Delta Math will accept any form on this answer here, I am going to clean it up a little bit because there's a few things we can combine. So right here I have a 4, and I have a 1/2, and I have an 8. Okay, I also have a negative here, and a negative here. All right, so the negatives are going to cancel each other out. And what am I left with? I'm left with 8 times 1/2, which is 4. 4 times this other 4 here is a 16. All right, that's going to leave us with sine of this times this. All right, that's a little bit cleaned up. Now, that's even easier to plug into Delta Math. Now, I'm not going to do this for every example, but I do want to make sure that we review how to rewrite these things as one fraction. So what I have here is I have 3 factors. I have that factor times this factor times this factor. Okay, let us proceed. 1 factor at a time. Well, this one is just a 16 in the numerator and a 1 in the denominator. So we just need a 16 here. We don't need to write the 1 downstairs. Let's move on to the next factor, the sine function. Well, that just has a positive exponent. The sine, it's just sine of x. It's a sine function over 1. So that just stays upstairs. It's a sine of this. Let's move on to the next one. So this factor has a negative exponent. That negative exponent means it goes downstairs. And it is going to look like this. Okay. If they go through the trouble of rewriting the negative exponents, they are usually going to go through the trouble of rewriting it back into a radical form. So let's do that also. That's going to look like this. And there's going to be someone out there who wants to cancel those out. You cannot, you cannot, you cannot, you cannot. This is the sine of something. Remember, this is the angle value, and you must have an angle value with a trig function or else it doesn't make sense. the sign of something. So you are not just allowed to do that and make it the sign of nothing, okay? That is not allowed. All right, I'll leave that. So then I just want to make sure that you do copy the right answer down. The right answer is going to be this. Okay, and you can't really do much more than that. Let's do another problem. Here's our next problem. Let's see what we have going on here. Let me move that over. Okay, so we are forced to use the product rule. Look at this. Whoops, that's terrible. Hang on, let me do this. There you go. That one times that one. You cannot really combine these. I mean, I guess you could distribute the cosine, but that's just going to make more of a mess. You're going to have two product rules to do. Let's just start with the product rule. Okay, we have two different functions. And it's in this format right here. This is the product rule as a general reminder, right? We're going to consider this function right here our f function, and this one our g function, and when we say that, this should make sense, correct? If we take the derivative of y, well then it's really taking the derivative of a product of two different functions. Here is the product rule. I will leave it over here. Let's continue. dy dx. Notice here our f function. We have to use the chain rule right here. Okay, we have to do 3 in front, leave the base, reduce that by 1, then take the derivative of that. Our second function g of x, we also have to use a chain rule in there. So we're using two chain rules inside of a product rule, because that is not just x, that's 2x. Let's continue. The derivative of f is going to look like this. Let me do that in a different color. We have 3, we leave the base. We reduce the exponent by 1, then we multiply it by the derivative of the base, which becomes 6x squared. Okay. We leave cosine 2x. Plus, now we leave the first one, which is f of x, which is 2x cubed minus 1 cubed, and we take the derivative of cosine of 2x, which becomes negative sign, leave the 2x, then multiply it by a 2. Okay? Remember the 2 goes here in front. That right there is the product rule. That right there is your answer, but I am going to clean it up a little bit because it is pretty darn messy. We have two terms. We have that term plus this term. What can we do here? Well, I can combine these two things. That's an 18x squared. I can't distribute into here because it has a 2 as your exponent. Don't forget about your cosine of 2x. Okay, that's about the best I could do. And then over here, well, let's see what we got. We have the 2, and I have a negative, so I guess I could put the negative 2 in front. Let me erase this here. And that is going to become negative 2. And then I got this. Can't distribute in there. It has a cube as an exponent. And then don't forget about your sine of 2x. All right, that's about all we can really do. Ta-da! Our next example gives us a cubed root of a fraction. Nice. Well, I hope you're in the habit now of when you see roots, square roots, cubed roots, and all that you think of a fractional exponent. That's the first thing you should do. Now, the whole thing is raised to the 1/3. What's that whole thing? Well, the whole thing is 2x over 6x squared plus 5. So what we have is something like this, where we are going to use the power rule, right? I'm going to put the 1/3 in front. I'm going to leave the base. I'm going to reduce the exponent by 1. But then it's time to take the derivative of the base. Now, when I take the derivative of this base, that is going to be using the quotient rule. That's why I wrote it over here. I will make it a little bit bigger for you, and we're going to leave it on the side here as a reference. But when we have a function that is the product of two different other functions, and we take the derivative of it, that's what we discussed in an earlier video. Let's put it here and continue. All right, so we are going to take derivative of this. This is going to become, oh wait, hold on. I have dy dx. Now, like we said first, we're going to put the 1/3 in front. We have to leave the base, and then when we reduce that by 1, that's going to give us what? That's going to give us negative 2/3, right? And the base we said was this. now it's time to take the derivative of the base, and we're just going to multiply the whole thing over here, and we have to use ourselves the quotient rule. So the derivative of the top is 2, you leave this. Minus, you leave the 2x, and you take the derivative of the denominator, which ends up being 12x. It's all over the denominator squared. Just leave it. You don't need to multiply that out. The denominator, that is. But what I would do, I highly recommend you clean up the numerator here. It's even just easier to type into Delta Math to bare minimum. So we have ourselves a 1/3, this right here, negative 2/3, and what does this give us? Well, this is, hang on, change the color. This is going to be 12x squared plus 10. Minus 24x squared. This one and this one is going to be 10 minus 12x squared. All right, so this at least makes it a little bit easier to type into Delta Math. Oops, here, let me do that again. And since your directions right there say in any form, there's your answer. Let us review this outline real quick since I'm not going to see you. And if you have not finished this homework assignment, you can definitely finish it. I just reviewed some more problems in this video that will help you. You could also jump over here to day 4 if you are done with that and start 137, 138. I'll show you what those look like in a moment, but this video, you should be able to handle everything that's asking you. Be on the lookout for a video on abstract chain rule. Okay, so 210, be on the lookout for a video there. This is what 137, 138 look like. So 137 is asking you to do questions over here where you're going to evaluate these, find the derivatives, and then you're going to plug in the value, find the derivative at a point. So you find the slope of the tangent line, plug in your x values, or your t values, whatever it might be. The graphing utility, I'll show you in class how to use your calculator to check yourself. Right, for right now, just do it the way we did in the video. The other page is just taking it one step further. We're doing up to 81 odd here. So on 138, we're not only going to just find the slope of the tangent line at a certain point, but we're going to find the equation of the tangent line. So don't forget your point-slope form. Again, I'll show you the graphing utility, the calculator in class.